Page 3, number 7, braking distance. What is misleading about the graph? Well, if you look at this graph, it looks like the Lexus takes half the distance to stop as a Lincoln and 3/4 of the distance of a Saab. However, they haven't shown you the whole graph. They've only shown you from 175 to 205 feet. If you were to put in the whole graph, then it's a much smaller fraction. So what's misleading about this particular graph is they've left off the rest of the graph from 0 to 175, which distorts impression of the difference. It makes it look like the difference is much more percentage of the total amounts. But if you had the whole bars on it, then it would look like they're not that much different if it went clear back to 175. So what percentage of the linking stoppance is the Lexus? Well, the Lexus stopped in about 188 feet, presumably. Might be meters, don't know. But a percentage, you don't need to know the units, just as long as they're the same units. And the Lincoln stopped in 206. And the reason I'm doing the Lincoln in the denominator, Lexus in the numerator, it says what percent of the Lincoln, so it's based on Lincolns, and so Lincoln has to go in the denominator. And so when you do that, you get a percentage of 188 divided by 206, and you get 91%. So this looks like about 75 or 50%, but it's really 91% if you consider the whole graph. The correct relationship. Okay, number 8. Determine whether there's a correlation. Well, it looks like there is a correlation because it looks like it's going down, and so it looks like a negative correlation. And determine if it's a strong one. Well, these dots seem fairly close, so I would tend to say fairly strong. They're not right on the line, but they're close to it. So I'd say not real strong, but fairly strong. And that's kind of a vague term, but a weak would be they're all over the place, kind of in roughly going down. So it's a negative correlation that's fairly strong. If there is a correlation, which there is, then you have to decide whether it's coincident, causal, or there's an underlying cause. So, temperature versus precipitation. If the temperature is higher, precipitation's down. Do you think the higher temperature reduces the precipitation? Do you think that's the reason? Is the temperature causing the change in the precipitation? Well, it might be, it looks like it's related, but I really don't think the temperature is the cause of the precipitation. It's the temperature is controlled by the angle of the sun, and the angle of the sun also controls how long the days and nights are, and it controls the weather patterns where the jet stream flows over the country. And so it's the time of the year that controls the temperature, and it also controls the amount of weather because it controls the jet stream flow. And so this one really is an underlying cause. Now, you might be able to make an argument for coincident or causal, but really this one's an underlying cause. When you have shorter days in the wintertime. You tend to get less warming, and in the wintertime in the Pacific Northwest, the jet stream tends to flow more directly onto Washington than it does in other places, or wherever this place is. It seems that the weather tends to hit stronger in the winter when the temperatures are lower, and higher in the summer when the temperatures are high. So it's not the temperature that's causing this rain pattern. It's the time of year, which is based on the tilt of the Earth. So it's an underlying cause.